Hi, everyone. Welcome to the State of MLOps. This is a shared event with DagsHub and New Relic. And we're doing this event to celebrate the announcement of the integration between DagsHub and New Relic. When we first recorded this event, we had technical difficulties. And so we are re-recording the intro and the demo of the integration. The event itself is going to be a 30-minute discussion about the state of MLOps, talking about the existing sort of ecosystem, how to make smart decisions about which tools to use, and a lot of other interesting things. So stick along with us. And so, yeah, let's get started. Basically, what we're doing with the DagsHub New Relic demo is we are combining DagsHub, which is a place where you can manage the different components of your data science or machine learning projects. So you have your code, your data, models, experiments under one roof. And all of this is built on top of open source tools like Git, DBC, and MLflow with New Relic, which is a great tool to monitor whether it's classic compute, or in our case, we'll show how to monitor experiments running in real time. And so let's get started. So I'll share my screen. And what we'll do is we'll work with this notebook that I prepared. And what I already did here is a lot of configuration just to save time. So we're basically importing a bunch of libraries. We put in the sort of different parameters to authenticate in front of DagsHub. You can use this notebook. We'll share it as part of the description on the video. We got the access token configured Git, and we've already cloned the repository, so you can see the files within the New Relic demo here. And we've installed a bunch of different packages that we're going to use. And then as we speak, I'll just modify this, and I'll explain in a moment what's sort of going to happen. And now we're going to pull sort of the various files that we need from DBC. And so this project is actually here on DagsHub, and this is open source. This is a fork of a project called Baby Yoda Segmenter. And what we're actually doing here is we are trying to segment Baby Yoda, or Grogu, from the TV show Mandalorian. So hopefully there are some fans in the audience. And so we're not going to focus on what's happening here from a ML perspective. The idea is, at a very high level, we are fine-tuning a mask RCNN model, and we're using MLflow to track the experiment as it's going along. And so hopefully we'll pull the various files in a moment. And what we can see on DagsHub in the meantime is we can see that we have our code files here. We also have data, which is tracked by DBC, but you can still see this within the file structure as if it was part of your code. So actually, let's go to the images just so you can see what I mean. And so you can actually see the different images that we're referring to as part of this platform. And then we also have the experiments tab, where you can see the different experiments that you have run in the past. And here again, we support either Git experiments, which means that you commit your parameters and metrics as human readable files, so CSVs and YAMLs, or you can use MLflow, which is a very popular open source tool for experiment tracking. And so by now we've pulled the data, and so our data exists on our Colab notebook as well. And now let's set up the sort of MLflow configuration. And what we're doing here is we're adding the username and token for DagsHub. And every project on DagsHub, when you create it, it comes with not only a Git server, as you would get maybe on GitHub, but also a DBC and DBC remote, where you can push your data and models and everything, and an MLflow tracking remote. So this is built in. And so what we're actually doing is we're taking this URL and putting it here, and that's it. And so the next step is we're going to run the DBC, before we run the project, we need to make sure that we have the integration with New Relic. And the way we're going to do that is we're going to go to settings, and then click integrations. And then we're going to we have a wizard here where we can click New Relic, It's going to guide us through the integration process. So I've already created an account here in New Relic and activated it. And so what we're going to do next is it's going to ask us for an account ID and a New Relic insight key. And let's delete these because this is not actually the right parameters here. And so to get these from New Relic, we're going to go here and click create, we're going to go back to the Explorer and we're going to do add more data. And when we do this, we're going to go down to the integrations and choose DagsHub. Now, we already have an API key that we've created. And so I'm going to use that one. And so this will give us the password or the insert key rather. And to get the account ID, there are a few ways to do this, but the easiest one is it exists in the URL. So account ID equals, and then we have this number. Oh, sorry. So we're going to use the number here and just copy it into this dashboard. Next, and that is it. We are now ready to run the new experiment. And so let's do that. So I will run this. And what this is basically going to do is fine-tune the model, as I mentioned before. It's going to log the metrics to MLflow, and those in turn will be transmitted to New Relic. And let's see what we can do with them. So the first thing that's going to happen is the model is going to be downloaded. So this will take a few moments until we start the actual training. And in the meantime, if we go here and click see your data, it's going to redirect us to a dashboard that is currently on 0 because nothing has been logged yet. But if we go back to the experiments tab, we now have a new experiment that you can see here, just started running. If we open it, we'll see there's no metric data logged yet, but we see that an experiment has been created. And the moment the training session actually starts, then we're going to see that there are values for the metrics. I think this should already work. Just a moment. Okay, so it'll take a few moments. We need to finish the first round. Okay, so now we're going to see some data. Okay, awesome. So we have one number, and the moment more numbers are going to be logged, it's going to turn into a chart. And we're going to, refreshing this on New Relic, we're actually going to be able to see this point now here, which is the same value as on DagsHub. This is 0.721 and loss. Awesome. So we have the same thing. And now let's talk about the awesome things that you can do with New Relic. So with the New Relic DagsHub integration, let's say I want to see a different metric, not the loss. I can duplicate this widget and then click edit here. And then we have the NRQL, which will let us change the metric that we want to see. And we can, let's say I want to see not the loss, but the loss mask. So all of the metrics are under DagsHub dot and then the name of the metric. And the nice thing here is if we want to do some custom analysis, we can perform different actions using NRQL and then see custom metrics as part of this chart. And you can see that I already have another point. Now, this chart will look similar to loss, but the values are actually going to be different than the one we have here. The other thing that we can do is we can create alerts, which is useful because a lot of times when you train, you don't want to sit next to your computer waiting for something to happen. So something might be either training fails or hopefully that the loss converges and we're actually able to learn something. And so with this integration, we can actually create an alert condition and basically, let's say loss, let's call it loss converges. And then we can basically set a threshold. What we're going to do is we're going to set that threshold to be static and choose basically, we want to define this as below 0. Let's say 5 for at least once in 1 minute. And then this is the threshold that we've defined. And then let's let's choose a policy. So I've already defined a policy for emailing me. So what I want to do is actually get an email if the loss converges. So I'm going to choose the policy that I made and then save this condition. And so what's going to happen here is basically you can define a policy which will be set assuming a certain condition is met, and then you'll get an email for that. That is something that you can do with the New Relic DagsHub integration. And I think this is a good point to move on. And so to introduce the guest that I'll have with me today, I'm joined by Ori Cohen from New Relic, and let's dive into the main event. And yeah, on to the sort of main discussion. So for this,
I'm curious. Maybe we can unmute everybody.
Yeah, so everyone can unmute themselves if you have a question. I'd still prefer if we do this via the chat, but if you want to ask in your own voice, you can do that as well.
Yeah, do we have similar graphs displayed in New Relic? Similar? Can we display the same graph in experiments, DagsHub experiments?
So if you're logging an experiment with MLflow, you can see the core metrics that DagsHub provides in New Relic as well. But one of the things that you can also do is, for example, if you want to perform some more sophisticated analysis, the DagsHub metrics are basically the things that you're logging with MLflow. With New Relic, you, for example, can run these queries and show more interactive views. So maybe you want to see two different charts at the same time, or multiply two metrics and see a chart of that sort of result. And that's something that you can do with New Relic, which might be convenient, especially if you don't want to, if you might want to look at something that you didn't log beforehand. So that might be useful for that. Does that make sense?
I mean to say that do we have the similar graph, the same projection, same thing, similar in DagsHub, or is it separate, completely separate? Both are separate. The experiments.
So the DagsHub experiments are on DagsHub, and then if you build this integration, then an MLflow experiment that you run will be logged to New Relic as well, and you can see the same charts that you see in DagsHub for the MLflow experiments in New Relic as well.
Okay, got it. Thank you.
Awesome.
Yeah, but
sure.
The added value is that you can kind of productionalize the whole thing and add alerts on top of them, and kind of leave your computer and come back if something has gone wrong. You can get it via a notification channel to your Slack, PagerDuty, whatever, etc.
Yeah. Awesome. So Ori has already sort of been involved in the demo part as well, and telling me that I didn't start recording. But sort of let me introduce him. So Ori holds a PhD in computer science, and he is a lead researcher at New Relic. He's also the creator of both the machine learning and deep learning compendium and the website stateofmlops.com. So he's very relevant for the discussion that we're going to have. And so let's sort of dive right into it. What are the key challenges around MLOps today, in your opinion?
So the key challenge in MLOps is MLOps. Now, just kidding aside, there are many new challenges that are coming up, and we can identify them from a data science point of view. Basically, every day that we're working with machine learning tools, and some of those challenges, I can name a few, but let's start with the closest one is what is your training strategy? So, for example, you've taken a model into production, and basically, like the first thing you do is train a model periodically or chronologically. Like, let's train a model every week, but is it the right approach? And I'm not familiar with any tool, and I don't think there is one, a tool that will allow me to kind of do more AI-driven approach into training. So maybe chronological is not the right solution. Maybe I need something which is based on I don't know, maybe a different model that selects the proper time to train, or maybe something that is more tailored made for the business problem or the product product problem that you have. So that's the first one, deciding on the training strategy for your models. The second one is kind of similar, is a deployment strategy. And what we normally do is once we train a model, we push it into production, but that's probably not the right approach. Maybe we can use some kind of a monitoring tool, maybe, I don't know, Relic, for example, to kind of figure out what were the metrics, the validation metrics for previous models, and kind of do something like look at the average validation metric, and I'll look at the question in a bit, and just look at the average plus some kind of a statistical deviation on a time window historically, and kind of figure out if the model, if we want to promote a model into production. I hope that makes sense.
Sure. Yeah, Abid is asking about data drift, concept drift, and sort of skewness, which I think relates to the next, to sort of some of the other challenges that we're planning on discussing. But do you want to sort of respond to that?
In the context of DagsHub, or?
No, like in how do you sort of, whether or not you think this is a key challenge, or if this is a challenge that you see in your work with data.
So first of all, tracking data drift and concept drift, those are key challenges. There are many tools out there. We have a few partners. I won't name any names, but we list a few other partnerships that are able to track data drift and concept drift, and they can do that for every data segmentation that you have. So if you have, I don't know, maybe a few categorical features, you can look at the data drift for each and every one of those segments and track them across time. Can we have a tracking of a level of continuous training? I think you can with those tools, but then can you answer in context of DagsHub?
Yeah, I think that from our perspective, one of the things that we're seeing is obviously you can have what sort of with tracking for whatever you want. The question is, what are the trade-offs, and what is the investment that you need to put in advance? And so I'm actually going to speak about how to think about addressing MLOps tooling challenges from first principles in the end of the month in another event. And I think that sort of the correct approach here is to be problem driven. So not to start by assuming that you need to track every level of continuous training, but actually looking for the bottlenecks and then trying to solve those. And then specifically from our perspective at DagsHub, I think that one of the nice things is that there are so many great tools to choose from, but sometimes it's confusing to know which tools to choose. And so mixing and matching sort of the tools that are most suited for your needs, and then being able to connect them in a way that makes sense. So not just transferring data from tool A to tool B, but actually thinking about what the workflow using these two or more tools makes sense is one of the challenges that we see in a lot of different places related to MLOps. And also, I think that our personal approach to how to solve this is that there is a lot of inspiration to be taken from the world of development, which is obviously a bit more mature than the world of data science. And so I guess this leads me to the second question, which is, what do you think data teams can learn from sort of the experience or the maturity of developer tools? So
maturity of developer tools. Seems like every new tool kind of solves a slightly different problem. And at times people are kind of MacGyvering everything and selecting, using known tools kind of in a different way, thinking out of the box. And I think those concepts can be passed on to data science teams or data teams. And for example, New Relic is not wasn't built to track machine learning models, but we found ways to do that in multiple partnerships. And now everybody can use New Relic, and for small data science teams, they can just create an account, log on, send insanely amounts of data and for free, and use the system to track machine learning models and to get alerts on them, to get incidents, to treat incidents, to figure out if there was a problem, a production problem. So going back to using tools in a slightly different way, if we take it, if we think about it from a data science point of view, we've done this early on from using regression models as classification models. So you can just bucket a regression and use it as ranking, or use it as classification, or kind of repurposed embedding algorithms such as word2vec in a kind of innovating ways, as long as you create something that looks like a sentence. If you take, for example, I don't know, a song list, and every song name is a word, and the song list is the sentence, you can create an embedding space based on song links. So and you can kind of figure out if I don't know, users are listening to the same thing, and various other questions, research questions that you care about. So I'm sorry, there's a helicopter, so I'm gonna pass the question to Dean.
Yeah, no, I think that makes a lot of sense. The way, like, I think one of the key examples that we're seeing for this is like Git, right? Like Git was a tool that was originally built for software development and to manage code versions, but with the right sort of add-ons and adaptations, namely sort of DVC is sort of one core example. You sort of expanded the capabilities of Git to the world of data science. And even if you're not talking about DVC, all of the tools I think today that provide some solution for data versioning that are sort of built specifically for that task are taking a lot of inspiration from the Git model. So the idea is that a lot of times, if you're reinventing the wheel, that is a good indication that you should probably stop a moment and check what exists and might maybe require small adaptations to use for your use case, because the added benefits, again, of using these tools that were originally made for development and then adapting them to your needs is that they are arguably significantly more robust. They are much more battle tested and have been used in a lot of different use cases by a lot of different individuals and teams. And so you gain a lot of benefit from their experience. This sort of answer also applies to build versus buy. But I think that it's very true in the case of data science toolings. And I think that, again, like at a high level, you can take a lot of the DevOps tools and methodologies, and then assuming you apply the correct ML twist, then you get something which is also good for data science. And I think that ML twist is first and foremost sort of treating data as part of the source code, or being data first. So I guess the next point, so like the term that now everyone is talking about is data-centric AI. And I think it would be interesting to discuss sort of what is a data-centric approach as opposed to a model-centric approach.
So data-centric AI, and everybody knows that Cohen kind of coined it maybe a couple of months, 3 months ago, and I was there in his first presentation when he was talking about model-centric versus data-centric. And so up until now, everything in our industry, in data science, was always, or mostly, I don't know, I can say probably 99% was model-centric. And we were trying to improve models or model performance, and we've gotten to a degree that every small change, like a point something, has received great congratulations and record-breaking models that, I don't know, frankly couldn't have been moved from one domain to another, but have received a lot of coverage. So talking about model-centric, what are the things that all the things that were done in order to improve models? So we have a vast array of algorithms, and we've talked about it. So from trees to random forests and XGBoost, and from simple neural networks to adding normalization layers and attention layers, and just name your layer, and you can probably add some kind of an improvement over previous work. We have gotten a lot better at using, since we didn't have enough data, we've gotten a lot better at doing bootstrapping, fine-tuning, transfer learning, zero-shot, one-shot, multi-shot, sorry. And it made sense because data data quantity was expensive, and playing around with models and trying to, well, playing around is not the right terminology, I don't like that, but researching models and trying to improve them was kind of more approachable. And nowadays, the models are really good. We don't really need more model improvement. So the focus goes to the data. So a data-centric approach, which we'll hear about probably in every Medium article and every meetup and every presentation, how to improve your data in order to improve performance. Yeah, so I don't think I have anything additional to say about that, but
yeah, I think that it's like you said, and I think we discussed this one of the other days when we spoke. It's like it's a matter of bottleneck. So for a long time, it seemed like the harder to solve bottleneck was sort of data quality or data quantity, and so it was easier to focus on modeling. And I think even more so, let's admit, sort of working with models seemed sexier. So I think it was very attractive for people to. It still is. Yeah.
Never ending. Yeah.
So people sort of naturally gravitated towards working on that. But we've improved modeling so much and left data so far behind that it's now at the point that improving the model further is going to yield almost no significant improvement, whereas small improvements in data quality are going to push you forward in many times. Obviously, this is generalizations, but in many cases, this is what's going to be the next sort of quantum leap for a model that you're working on. And so I think the data-centric approach, like if I had to summarize it into sort of this one sentence, is it's the realization that the next solvable bottleneck is around data. And so we should put resources into solving that. And so assuming we want to build data first or data-centric system, how do you define sort of the challenges or considerations around that? And how can we approach this in a more let's say technical level? Because as you said, it's like a buzzword now, so everyone is saying like data-centric, but and except for like getting more data, like how can I be more data-centric?
So I'm also one of those that has, I started an article Medium. I didn't finish it yet, but it says something about being data-centric. Yeah, to be continued. So what do we need in order to be more data-centric? So first of all, obviously we need data, right? And getting data is probably the biggest challenge. and we always have that trade-off between having a supervised problem and an unsupervised problem. And it's usually easier to solve supervised problems, right? So the challenge in creating a supervised set is data annotation. It can be automatic, it can be human annotation, but you need to somehow create your own data and your own data labels. So that's a big challenge. It's a whole world onto its own, and annotating data. There are many theories behind it and formulas to measuring agreement and disagreement. So that's one thing. Obviously, EDA, exploratory data analysis. With the explosion of data, figuring out a way to do EDA automatically. If anyone wants to create a nice startup that does that for you, I think it will be a hit, and it will solve a lot of time. So because data is dealing with data is a time sucker, so it sucks all your time from doing other more sexy things like building models. And if we can shorten the time to figure out if the data is clean, if it's noisy, it can help a lot of people. I want to touch on a few points of how to, so what tools do we have in order to identify bad data, right? So there are a few tools. You can do type validation. So just imagine a table-based data set, and you have a few features, and one of them is categorical, the other is integer-based or floats or whatever. So the first line of defense is figuring out if data that is coming in is in the wrong type. And if it's in the wrong type, it will influence the model and influence everything downstream, including the client. So it will be a client-facing production problem eventually. The second thing that you can do is actually look at the data. So if you have, for example, a categorical feature, you can look at all the historical data that you can look at and figure out what is your set of categorical values that you have. And if there's a new value that is coming in, you can set an alert, and you can inform the data scientist, and he can figure out if there's new data, which relates to all the other tools of data drifts, concept drift, etc. And there are a bunch of good tools to use, like TDDA, which is a test-driven data analysis. It's you can go over to GitHub. You can probably find it quite easily. It's so think about it like you take a pandas data set, you create a snapshot, and everything later on that comes, if it's not in the right type and the right values, will not pass, and you will get, and you can kind of set it up that you can get the trigger. Other great packages that you can use are Great Expectations, and I think that they are coming up with a SaaS-based solution soon, so that's kind of cool. So heads up on that. So basically everything that you can protect yourself from bad data, missing data, new schemas, etc., is probably like the first good approach that you can, like the healthy approach that you can take in terms of data.
I think one of those things that seems like it's more work than it actually is, and you can invest a bit of time and save a lot of heartache afterwards. I think that we're already a bit over time, so I think what we'll do now is we'll sort of say thank you to everyone who joined. You can stick around and ask questions if you want. But yeah, so first, thank you to Ori, who joined me for this event. It was awesome. And don't worry about the demo. We'll add another version later, so it's part of an integral part of this sort of a video. And thank you to the sort of audience that joined. You were awesome as well. And if you have any questions, then we're sticking around for a few moments. So yeah, have a great evening or morning, depending on where you are. And thank you again. So you have a new fan. Anyone else? If you have any questions, let us know.
I have a question for everybody. If people are still staying, do you think that you will use the DagsHub New Relic integration to see audio metric in a central place and to get alerts on them? Is it something that makes sense to you?
Can I say something?
Yeah, sure.
Yeah, I think while I was like listening to you, I started the project behind on that integration. But I think I will use it in the production level, more on production level, like uh, training inference and other to track the other parameters. Like I might like play around to check out what can I use, what can be done, because I'm not satisfied with just tracking model performance during training. I might go further for what are the what are the feedback from the inference or the production instance, how many wrong, how many false positive we are getting, like those kind of metrics. I might go further, but yeah, I might use this integration for that. And I have one more question, like can we it's a general question, maybe out of topic. Can we all move from like simple raw data and move to more towards graph-based data, or to just reduce a lot of pre-processing, a lot of cleaning, or a lot of, we can just feed those graph data and we can just we have a software, we have architect, we feed those data just like model, we feed those data and we solve a lot of reproducibility problems, we solve a lot of coding error, software error. What do you think about that?
So you said something about doing less pre-processing, or like trying to utilize some kind of a graph structure in order to do less of data processing. I'm a strong believer in data processing. And even if you're using, and I hope I'm answering the question, but even if you're using like a neural network, you need to do your feature engineering. So I don't think that will ever go away completely, unless there are some tools that will do it automatically for you, like be really super smart and that I can trust them. And if you can kind of clarify what you were talking about with the graph thing.
Just like in a TF transformation, TensorFlow transformation, they also have a graph so that you can have multiple production instance for web TensorFlow JS. You just code once and it transfer all of your the main idea, the transformation, min max, whatever you have done, and it can transfer to other languages, your production instance. You have mobile, you have edge instance. So it just transfer all those. It's not transferring the code, it's not translating the code, but the data is in form of graph. So what it does, the same library just catches, or same language that captures some amount of those data, those function, how these are linked, how the transformation, how the pipelines are built, and it just added to the production inference, and it reduced a lot of your time processing and a lot of coding, like the problem, software engineering problem, the testing or the errors that you get.
I actually have to see an example to figure out like if there's a if I can answer that. So really sorry, maybe Dean has some kind of
like I'm also not 100% sure I followed, but if I understand correctly, you're talking about like there are standardized formats for models which let you sort of translate a model from the original language it was created in or trained in to other places where it can be deployed, like ONNX is one example, and PMML, and you have a bunch of these different things. I think that sort of the challenge with data is that it's a more general thing, as opposed to models, which you like for all of these solutions, it assumes a lot of things about the model. And that the point about the data is that a lot of times, no matter what restraints you put on the data, and Ori sort of mentioned this, like in the sense of data validation and everything, you might still want to be able to treat outliers and things like that. So you might be limited, and you're more limited in your ability to do something equivalent with data as you would for model architectures. But it doesn't mean that it's not possible. It just means that you need to sort of pay attention to more to smaller details, maybe. So I guess I'll thank everyone again. I hope you enjoyed this, and please feel free to sort of reach out to us, whether it's on the DagsHub Discord channel or I don't know, LinkedIn or Twitter. And yeah, have a great evening, everyone, or morning, and we'll see you around. Bye bye.